During this lesson, we will learn about another application of percents, simple interest. When you deposit money in a bank, the bank pays you interest for the right to use your money for a period of time. To calculate simple interest, we take P times R times T, where P stands for the principal, which is the original amount of money deposited. R stands for the interest rate, like maybe 2% per year. T stands for the number of years the money is in the bank. And I stands for the simple interest. So as we keep our money in the bank over the course of several years, we get 2% of our money added on every year. So 2% of 100 is $2. So after 1 year, we would get $2. After 2 years, we would get $2 more. After 3 years, we would get $2 more. And that would continue. Simple interest is always only based on the principal amount. So you will continue to get $2 because you started with 100. Suppose you deposit $400 in a savings account and keep it in the bank for 6 years. The annual interest rate is 5%. Identify each value in the simple interest formula. First, we'll look at the variables. The interest is represented with I, principal, P, rate, R, and time, T. The amount of interest we don't know at this time. The principal is the amount of money that you begin with. So we deposited $400. The rate is the annual interest rate of 5%. Now we wouldn't just use 5 because that's not the same as 5%, but we would use the decimal 0.05. The time must always be in years. So when we look, we see 6 years, we use 6. Now we just multiply these values to calculate our interest. We would do 5% of $400, $20, 6 times since we're keeping it there for 6 years. So $120 is our amount of interest. Suppose you deposit $500 in a bank account that earns simple interest at 1.2% per year. You keep it in the bank for 2 years. Which of the following are true? Okay, so our formula says that the interest is calculated by doing P times R times T. Our principal is the amount of money we begin with. Our rate is 1.2%, but we need to write that as a decimal. So we would move our decimal to the left 2 times, 0.012. And our time is always in years, 2. Okay, if we multiply all this, 500 at 1.2% would be $6 for 1 year, but we're doing 2 years, so we times that by 2, and the interest is $12. Okay, so P was 500, R was at 1.2%, T was 2 years, and I was $12. I is 12, R is not 500, P is not 1.2%, but T equals 2. How does the formula for simple interest after 1 year relate to the percent equation? Well, let's check it out. We have the formula P times R times T. If T is 1, then we would just multiply by 1, so it wouldn't do anything. It'd just be P times R. R is always a percentage, so it's our percent. Interest is a part of your money, and the principal is the whole or the original total that you begin with. So this is kind of our important information, I guess. The R is like the percent, the interest is the part, and the principal is the whole. Now, another vocabulary word that we'll talk about when we talk about interest is the balance. The balance is like basically your new total. Hopefully that's a word that you're already familiar with, but if you're not, you can make a note. The balance is your new total. So after so many years, your balance is going to be greater than your principal since you're gaining interest.
I wonder if you might be interested in opening a CD account.
CDs? Who buys CDs anymore? I get all my music online.
A bank manager wants to encourage customers to open a certificate of deposit account. He decides to make a poster to show how much interest a CD earns over time. Help the manager complete the table. Okay, so let's just do this work over to the side. We have our formula. The interest we're calculating. The principal is $2,500. The rate is 0.035, 3.5%. And the time is different each time. So we could try times 0. Well, anything times 0 is just 0. So our simple interest earned would be 0. And so our account balance would just be the principal only. If we did 1 year, we have our principal, our rate for 1 year, we don't really need to multiply by 1 because it's not going to do anything. 87.50. So after 1 year, we would earn 87.50. We could add that to our principal and see that we would have 2,587.50 as our balance now. Go ahead and complete the chart. You can pause the video to do it. As you complete the chart, you will calculate just with a new amount of time each time you do it. Like we're using 2%, 2 years, then 3 years, then 4 years. Adding that interest that you find to your principal to get your balance. And here's how your table should look. A new bank customer with $5,000 to deposit looks at the manager's poster. The customer wants to open a CD to earn money for his retirement. If he wants to have $5,500 in the CD, how long does he need to keep the account? Okay, let's write down our formula. That's always a good place to begin. Now this time, the interest isn't exactly unknown. He wants to have $5,500 after starting with $5,000. So he wants to gain $500 in interest. His principal is his starting amount of $5,000. The rate, according to this account, would be 3.5%, so 0.035, and the time would be unknown. But we can solve for it. Now, we can go ahead and multiply these two values. $175. Oops. Copy the rest of the equation still. To solve, we would divide by 175 on both sides of our equation. 500 divided by 175 would be about 2.9 if we round. And that's years. So you would probably want to leave it in there for about 3 years. And then he would have the money that he needed. Sometimes interest is accumulated on a monthly basis when R is an annual interest rate. Annual means yearly or every year. We have to do some calculations because the time will have to be in years to go with our annual interest rate. So as an example, if you have 3 months, you just write it in terms of years. 3 months out of 12, since months are just a fraction of the whole year, be the same as having 1/4 of a year. So we could use 1/4 as our time. Let's try some examples. Okay, we have 2 accounts, Alex and Mia. For Alex, the principal will be $2,950. The rate 4%, and our time, we can't use 8 because that would make it seem like 8 years. We need to divide by 12. We can just write it as a decimal. We don't need it in fraction form. Oh, now, this is a good point to bring up. We have a 6 repeating. We use the bar over the 6 to indicate that it's repeating. Now, when you want to type that into a calculator, you have a few options. Already, you can see that I typed 8 divided by 12, and so I have this big 6 repeating, so I can just continue to type in my other numbers. Times 0.04 and times 2,950. So it's about $78.67 in interest. Now the other option, if you need to get a repeating 6, if you'll just type in several, the calculator is going to be accurate enough. It's going to get the idea and you're going to get a correct answer. And then you could just, keep typing in your other values. Also, kind of like I did already, you could just type in 8 divided by 12 and then times it by the other values. Okay, so Alex would now have how much for balance? Because it says who would have the higher balance? Well, he had a starting amount of $2,950. Add the $78.67. Let's see, that'd be 67 cents. 8203. There we go. $3,028.67. Okay, let's check out Mia. Her interest would be calculated with her principal, which she actually started with more money, but she has a lower interest rate, 0.25. We would use 4%, moving the decimal 2 times. And for the same amount of time, so 8 out of 12 months. Okay, so let's try this. I'm just going to go and do 8 divided by 12 again. So I get that repeating 6 in my calculator times 0.025 times 3,000. $50 in interest. Since her original amount was $3,000, we add the $50